Hello everybody. Thank you for attending CohuHD's 4290 HD night vision camera introduction. We'll be getting started right now. The agenda that we'll be discussing today is we'll do a quick overview of CohuHD's product strategy, a quick overview of the RISE platform, introduce the 4290 feature sets, and end up with some questions. So to go into the Cohu product strategy, we design products for critical infrastructure applications. That is our core market. The typical applications that we design products toward are ITS surveillance, high-end security, and military aerospace applications. Those applications typically have some common characteristics that are quite significant. Typically, they're mission-critical requirements. The cameras live in extremely bad environmental conditions. The products are generally very remote or difficult to access, endure very poor electrical and mechanical environments, and usually require long-distance surveillance. So those properties is what the Cohu product platforms try to solve. We introduced the RISE product platform about 2 years ago. RISE is an acronym. It stands for Rugged Innovation with Superior Endurance. We try to design all of those characteristics into the product platform. The 4290 is the latest addition to this RISE platform. Now the RISE technology refresh, we added new camera sensor optics. We're now adding the thermal long-wave IR camera sensor. We upped the encoding system on a chip technology for more powerful processing capability. We redesigned our motion control system for more accuracy and smoother, fluent operation. We redesigned the electrical and power system to support PoE++ power into the camera system, and have redesigned the enclosure system, where we now offer a lifetime warranty on the camera enclosure for any moisture ingress. So with that, the family of products has now been expanded. We have our dome line, which is the 4220 HD series. We have our single head visible camera positioner, the 4260 HD series. And we are now introducing our night vision platform, which is the 4290 HD. So the RISE 4290 HD series has inherited many of the RISE platform technologies that now have been out for a couple of years. So the technology that the 4290 inherits is been well deployed and has been well vetted. So the 4290 inherits the 4260 HD positioner features, which is the pan-tilt platform right here. All of that is inherited into the 4290. As well, you automatically get the visible camera head. So this platform here, it was the base that we started the 4290 on. As well, the command core software that we released earlier this year, which is part of the 4260, gets inherited into the 4290. The 4290 is the addition of the night vision camera head, which is a second camera head system attached to the positioner. And due to the powerful system on a chip encoding technology that was under the RISE platform, it supports a second camera system head. So we are just leveraging that capability and expanding it with the ability for night vision. Now the night vision camera head system is a standard definition long-wave IR vanadium oxide thermal core We offer a couple different lens options. One is a 6x continuous zoom with autofocus on demand. A second option is a dual field of view zoom with autofocus on demand. And then we have two different wide-angle fixed view capabilities. So it's primarily dependent upon your application and your budget as to which one of the standard depth thermal camera options that you would elect to use. So the options that we provide in the product, this is the model structure, which provides you an indication of all of the options that the camera allows, and it results in a final model number that you would order. So going through this, the first is the series number, the 4290, and then the first option that you have, again, since it's inherited all of the things that we've added into the 4260 over the last 2 years, one of the things the 4290 immediately inherits is all of the power and pigtail configurations. Now, this pigtail configuration list has been growing, and primarily the reason it grows is because CohuHD has been around quite some time, more than 40 to 50 years. We've got tens and tens of thousands of cameras deployed across the country and the world. And when customers want to update their camera sites, they want to buy the latest technology and replace the camera that was installed previously, but it is undesirable to have to replace the cabling infrastructure or the connector to do so. So the pigtail connections that the 4260 has grown to include is now inherited into the 4290. So what we have here is we have a number of PoE++ power options, or you can elect to use a 24-volt power or 120-volt power. And then the pigtail is terminated with a specific connectorization scheme that you just need to decide which one you need if you elect to replace an existing Cohu camera. The next thing you have immediately is the visible camera head as part of the model structure, and then you have to choose between your thermal options. As I mentioned, you have a dual field of view option. You have the 25 to 150 millimeter, which is a 6x continuous zoom option on the thermal, and you have two fixed focal lenses, which are 25 mil and a 50 mil. Now, each one of these thermal options has a 9 hertz frame rate output, which is primarily used when exportation outside of the U.S. is needed. By the time you've added up the different model or the options that you want, you come out with a final model number, which is what you would order. So this model number here would give you a 4290 series with the PoE++ power with the accessory pigtail included. You would have the visible camera option right there. I want the 25 to 150 millimeter 6x continuous zoom, and then these other options here are just future placeholders for further things we have in store down the line. The 4290 has quite a few different signal interfaces that you have options to use. The first thing, and this is an example of the model number that we just configured on the previous slide, the 4290. So the first thing that you get is the RJ45 pigtail coming out of the camera, which includes it's a Cat5e. All of the video for both visible and thermal ride on that Cat5. All of your camera pan tilt control ride on it, the web server configuration, and also the PoE++ power, all are carried on that single Cat5 cable, which is a very nice thing. If you didn't need analog or serial or digital I/O type capabilities, then the camera itself would only need an RJ45 pigtail coming out of it. The other thing is that you think, my gosh, I got 2 cameras, all this stuff, it must take more than 1 IP address. That's not true. The 4290 is a 1 IP address system And it's just through the software in our system-on-a-chip encoding technology that allows us to do all of this stuff using only one IP address. Now, on the model that we configured previously, we have the accessory pigtail, and that's just a second cable that comes out of the camera system, and that includes analog video, which you can have configured for either NTSC or PAL. It's got the serial RS422 for camera, pan tilt control. It's got 4 digital I/O signals that you can use to monitor and control external devices. And if you elected to use AC power, then you would have the appropriate AC power conductors coming out of that accessory cable. So these are some of the items that I'll cover going forth. On the 4290, we'll cover the daytime visible imaging component, the advanced night vision performance, the intuitive command core software, some of the screens that control both the visible and the thermal heads. I'll cover the automated action engine. Again, that's an inherited capability from the RISE platform that the 4290 gets. We'll go over the installation and interoperability capabilities of the product, and then go over the final, the ruggedized construction. So the daytime performance, it uses the same visible camera head as the 4260 platform, and that provides very good long-range surveillance. And how that long-range surveillance is accomplished is due to the full HD 1080p resolution of the image, along with the powerful 30x magnification optically, plus a 12x digital magnification on top of that. Just as an example, if you were to combine the 1080p resolution at full 30x optical zoom and add a 3x digital zoom component to that, that would give you the equivalent imaging capability of a standard def camera fitted with a 400 millimeter zoom lens. So as you can see, just by combining 1080p resolution with some powerful optics and a little bit of digital zoom, you can match a very expensive standard def camera with a lot of glass, a lot of magnification to achieve the same effect. With this, human-sized objects can be detected out to about 6 kilometers. As well, there's a very robust image enhancement compensation on the visible camera to address poor atmospheric conditions, such as automatic defog compensation, very challenging scene lighting conditions, such as very bright and dark areas in the same scene, can be handled by the wide dynamic range. In instances where you have a very bright spot that you just want that area to be reduced in brightness, it only affects that white, the very bright area of the scene, and then the converse of that, intensity reduction, which would be like headlights in very dark area, where the blooming effect of the image is greatly reduced due to that capability. Over to the right are just some of the command core interface screens for setting up the visible section of the camera. As you can see, you have a day-night mode capability, shutter speed, backlight compensation with an amount of an adjustment, wide dynamic range, digital slow shutter, and your gain control using very up-to-date controls. The defog you can set to auto or off or one of 3 levels, and then you set the amount of defog strength compensation you want, and you can add some defog color, which, as you know, what fog tends to do is it greatly reduces the scene contrast and color. Everything that looks washed out gray, so the defog compensation basically increases the contrast of the scene to bring things out, and then you can add color to it. Now, in the automatic mode, the camera will automatically compensate and decompensate as the scene warrants. And then you have some advanced settings, the intensity mode, as I mentioned, for the white out reduction or intensity control, which is a level that you can compensate for. There's image sharpness, just a number of different capabilities to optimize the daytime performance. Now, it's not just a daytime camera. The visible camera has got extremely good low light performance, and this can be complementary to the night vision thermal capabilities, where the night vision is great at detecting and recognizing there's something out there, but very difficult to identify, especially if it's a person, whether it's Pete or Paul or enemy or friend. You just don't have the identification capability in thermal that you do in visible. So combining the thermal performance for detecting something at nighttime and then using the low light performance capability of the visible, you can complement each other, and it works both directions, and I'll go through that in the nighttime, where the visible complements the night performance. Now, the low light performance, by using the true day-night IR cut filter, if I turn color off, go to black and white, then use digital shutter integration, that improves the normal day sensor sensitivity by a factor of 160. So very good low light nighttime performance for the visible camera. Then we go into the thermal night vision performance, and we decided not to even bother with using or offering the 320 by 240 resolution thermal detectors out there. It's just with HD so prevalent today, it just didn't seem to make sense to match a high definition camera with basically a SIF resolution thermal. So we standardized on a standard definition 480p resolution long wave IR sensor. Again, we have magnification capability up to 6x. Gives you about a 4.1 degree field of view when it's fully zoomed in. Image enhancements, we provide image gain control, so you can bring out very thermal contrast scenes that don't have a lot of heat signature to them. You can increase the gain to bring out the scene. It has automatic non-uniformity correction settings that you would automatically set for a certain amount of interval timing, so you don't have to manually do those types of things. It's got a polarity, a white hot or black hot setting, and then you can have color palettes applied so that the thermal image gives you the most information as far as what the heat signature of the scene entails. Now, the beauty of thermal night vision is that you need absolutely no light. It's not dependent upon any kind of reflected light from either the sun, the moon, the stars. It simply sees an object's radiated heat. With that, the thermal sensitivity is better than 50 millikelvins of sensitivity, meaning that the temperature difference between what it can detect is in the order of 50 millikelvins, which is a very, very low temperature. This as well can then detect human-sized objects out to about 5 kilometers. Now, with the second head, in trying to integrate in with replacing, say, a single visible camera, and you wanted to add that plus some thermal, but my control system doesn't necessarily have support for 2 camera heads, we provided a capability which we call synchronized zoom mode, and that allows the camera to follow either the visible zoom camera being zoomed, the thermal will follow that, or you can set it to the thermal, where if I want the thermal to lead, I can set thermal zoom messages lead and the visible zoom will follow that, or I can operate them independently. Now, in the case of backward compatibility, the visible lead mode would be desired, where what that means is that with the normal operator sending a zoom in on the visible camera, when they are looking at the thermal, that zoom lens will automatically zoom in, just following what the visible zoom is. Now we try to maintain the field of views within the area that the zooms have a similar field of view, so that when you are zooming the visible camera, its field of view and the thermal field of view should be fairly close or similar. Obviously, a 30x visible will have a little more magnification capability. So when you're at the far end, you would have a more narrow field of view than the thermal can do because it's only a 6x. But within the range that the cameras have a common field of view, the two will remain in sync. Another capability that is on the system is where most thermals don't have automatic focus. Ours does, but it's on demand, meaning that it doesn't continuously autofocus. It's you have to tell the camera when to autofocus. So again, on an integration to an existing system, they may not have that button available to tell the thermal to do an autofocus function. But what we allow is another mode that when you are panning and tilting and zooming, upon the pan, tilt, zoom stops, that will trigger the thermal to do its autofocus. Therefore, the camera will automatically focus without any operator manual intervention. So we took to heart the ability of operating this camera in systems where there isn't a dual head capability in place. Now, as I mentioned, the 4290 inherits the Command Core software. This was a major software release we had at the beginning of the year. It is very intuitive in operation and configuration through the page layouts that it presents to a user. It has built-in configuration wizards that just help you along with configuring more advanced capabilities of the camera. The Action Engine is one of those where the configuration wizard helps step you through pretty complicated configuration processes. All the time the interface is providing user assist prompts, telling you why something's disabled, alerting you if you're doing something that you may want to think twice about. It's just completely user-friendly in terms of navigating the operator through a good environment. The setup of your FTP site, there's diagnostics so that you can test to make sure the camera is properly communicating to the FTP site, so that you just don't sit there with a scratch on your head wondering what's going on. It will provide you good diagnostic feedback. We've got an advanced pan-tilt control panel as part of the interface, which is now dynamic. It will readjust itself depending upon which camera head that you've selected, because there are different capabilities between the visible and the thermal. And then whenever you find yourself and you just don't understand what a certain control is, or how to configure it, there are question marks, help menu items all throughout the interface that you can just click, and it immediately brings up a help dialog box for you. So lots of people wonder, well, how do I get two videos from one IP address? And partly it's due to the system on a chip that we use inside the camera system. It has two inputs that can be connected to the chip, and then it can encode and process all that information. But more importantly, the user interface. How do I go about selecting the visible camera versus the thermal camera, and say I want to look at both of them at the same time? So one of the things that we've added to the Command Core interface is the ability to manage video control of both camera heads. And what we've done is we've added some tabs to the video window, which then provides you three choices: the visible, thermal, or split. So depending upon which camera you want to look at, you just select the appropriate tab, and that brings up the camera that you want to use. This is an example of I've got the visible camera selected, so the visible camera appears. I can then just click on the thermal camera tab, and my thermal image appears. And I can also select split, which then displays both the thermal and the visible at the same time. Now, from a camera control standpoint, well, I'll get to that, I'm sorry. Now, from the stream setup, you're wondering, I've got 2 cameras, how do I set these 2 cameras up? The 4290 provides a page for stream settings, and the first thing that you need to determine is, am I setting up my visible camera or my thermal camera? So there's a simple button there, pick which one you want. You then define the stream that you want that camera tied to. And on the visible camera, there are 3 resolution possibilities that the visible camera can be set up for. It's 1080p, 720p, or 720 by 480, or 720 by 576. And that resolution, the 720 by 480 or 576, is really predicated upon whether you want NTSC or PAL analog video. Once you've made that decision, then the visible and thermal camera resolutions would follow either the 480 or the 576 vertical resolution format. Now, the thermal camera resolution, you have, and again, this is in terms of the analog output, 720 by 480 or 720 by 576, and then the IP video is either 640 by 480 or 352 by 240. So you can set any number of streams up utilizing each one of those resolutions or just 1 or 2 of them. It all depends on how you have the camera set up. Now, once you've got that set up, you attach it to a profile, and then once you have the profile set up, each profile will be connected to a stream which has either the visible or the thermal camera tied to it. And then from a URL standpoint, from the outside world, how do I connect to a particular video stream from the camera? This is a standard RTSP URL, but you would just assign the camera IP address, the stream number that you've assigned for the particular camera. In this instance here, I've configured stream 0 to be my visible camera. I can do the same RTSP, the same IP address, but use stream 1, which I've now set to the thermal camera. So that's how you have access using the same IP address, either the visible or the thermal stream. It just depends on how you configured the camera up and what stream number you have set for each one of those. So the pan tilt control panel in Command Core, this is what I was getting to. Once you select a camera, say the visible, what happens on the control panel is it's automatically going to adjust itself. There's only one panel. I'm just showing you the visible panel here, visible camera control panel layout here. If I selected the thermal camera, it would look like this, and it just changes on the fly dynamically. There's nothing an operator needs to do other than set focus on either the visible or the thermal camera, depending upon which one he wants to control. So a lot of the controls are constant. I mean, the pan tilt, there's only one, so that's common between the visible or the thermal head. But the zoom magnification slider will reflect either the 30x optical zoom or the 6x, or no slider, because it's a fixed focal length lens for the thermal. As well, the visible has all kinds of focus and iris support from a visible camera perspective. On the thermal, only focus appears, auto focus, or infinity focus. There is no iris on a thermal camera, so those controls go away. And I've discussed the synchronized zoom. Again, the purpose of that is having a single zoom command control both lenses. This in terms of an existing VMS that doesn't support dual head. You can easily integrate this camera system in, have full control of your visible and thermal cameras without needing any extra work done. Again, the synchronized zoom mode, the purpose is also to try to maintain similar fields of view so an operator doesn't have to manually move each camera field of view independently to line them up. Now, all of this capability is done through ONVIF Profile S. That's the RISE platform's native language. ONVIF Profile S is the native language of the product. We're very serious about this. We publish our ONVIF WSDLs, which we have available on our website for thermal cameras. We'll be working with third-party VMSs to get them to implement some of these extra capabilities. But in the event that they don't, it's not a crisis because, again, we designed the camera to operate within VMSs such that they do not need special zoom camera controls to operate the zoom camera. You can just put it in the synchronized mode. The 4290 inherits the RISE action engine. This provides fully automated camera responses. There's a number of sources that you can use to trigger the automated actions of the camera. You can use the digital I/O signals that are available through the accessory cable. An example of that would be a door contact. If the door opens, you want to have the camera go to a preset, take a snapshot of whoever opened the door. And you can have multiple actions for each input trigger. There's a programmable action list so that I can tie, upon this input activating, I want to take a snapshot. I want that snapshot to be sent to an FTP site. I want a contact to activate to turn a bell on, and I want the camera to move to a preset. All of this complexity is programmable through the built-in configuration wizard. So through that configuration wizard, it just takes you step by step by step to program each input trigger to create all of your output actions very easily. Now, in the event that there are multiple inputs that come in at the same time, you are able to provide a queuing mode priority so that you define if these events come in at the same time, this event has much higher priority, therefore I would want it to override a lower priority event that the camera detects. So there's a pretty flexible way to prioritize how the camera operates on a case-by-case basis. Some of the input sources, again, sensor contacts. There's a built-in periodic timer, so you could say every 5 minutes I want the timer to go off, which causes the camera to do an automated set of actions. I can have the camera do things based on a calendar scheduler, so every day at 8 a.m. I want something to happen, and then every day at 5 p.m. I want something different to happen. If you have the camera going through a tour of preset views, each time the camera lands on that preset, if you desire, you could have a snapshot taken. That snapshot then is sent to an FTP site as an example. If you want to know if the pan tilt camera has been moved, if it's looking at the bank vault and I need to know if it's not looking at the bank vault anymore, you can have a pan tilt move trigger an event. Any kind of a maintenance event can trigger the action engine, and video analytic events can trigger, and you can build your own user commands to do specific things based on the action engine. Outputs that the action engine, which is the work performed by the camera, I can turn on the relay contact to turn a light or sound a bell. can upload images to an FTP site, send out emails, activate presets, and display OSD messages on the video are some examples of some output actions. And here's just an example of traffic security. We frequently get requests where there's a lot of expensive equipment in the 334 cabinets, and they want to know if that door has been opened, and just lo and behold, there's a camera sitting right next to it, so that if that door opens, they want the camera to basically pan and tilt around and slew in to the cabinet, find out who's at the door. So this is just an example. The door opens, the camera goes to a preset, takes a picture, and there's an output to sound a bell to scare off the person. From a website standpoint, there are FTP sites that capture up-to-date pictures of freeway conditions. You could set a periodic timer on the product, have it go off every 5 minutes. The camera then sends a fresh snapshot to the FTP site so that you have fresh updates every 5 minutes that you can send off to your customer base. The OSD as well that we've built into the command core gets inherited. We've really optimized it for ITS needs. We have up to 7 different elements that you can display. The OSD is then common to both the visible and the thermal. So both videos will get the same OSD imprint. OSD element examples are you can have a user-defined text, a preset ID location, the pan, tilt, zoom position, compass information, date, time, a sector message, a maintenance event, alert. As well, there's an image banner, which is a dark section that covers the very top and or bottom of the video that you can put some OSD messages into. We allow you to upload your own font as long as it's a true font type library. You can have all kinds of fun with the look of the characters that you embed into the video. You have different font properties, the color, the background, transparency, where it's located, and as well you can add company logo to the video information. So a lot of this is based on the needs of the ITS community. Whoop. The 4290 interface, because it inherited the command core once again, is compatible with all the popular OS browser supports, Windows OS, with the Windows Explorer, IE. The camera can send an H.264 ActiveX component out, which Windows is compatible with, so that you get H.264 video displayable on it. As well, Firefox and Chrome, which do not support the ActiveX component, but the 4290 detects that it's Firefox, Chrome, and or Safari, and then configures the camera if one is not already configured for a JPEG image that then the Firefox and Chrome can use for displaying video. System integration protocols, all of the protocols that were in the command core are inherited by the 4290. Again, ONVIF Profile S is the native language, designed such that the camera can operate as the thermal really just follows along with the visible camera, so you don't need to worry about controls explicitly on the thermal side of the equation. That would also apply to NTCIP 1205, which in fact the protocol itself does not really have any support for a second head or thermal capability, but because of the way we design the camera, we just follow the video, the visible camera zoom functions and zoom the thermal through that mechanism. And then we support our older legacy protocols as well as some other popular manufacturer protocols that have been embedded. and that's all through the serial side. So again, the 4290 is a hybrid. It supports both digital IP over Ethernet, as well as simultaneously, if you elect to get the pigtail that exposes it, you can have analog video and serial RS422 control. Many sites have analog infrastructures. They've got to buy new cameras. They don't want to buy an analog that's out of date. So I want to buy the latest and greatest, but I need it to operate in an analog environment. So you can still purchase the 4290. It will plug in very seamlessly. That's one of the reasons why we have so many different pigtail options, is primarily due to the vast number of legacy products that have been installed and are now ripe for being replaced. And we just need to make sure that the camera can operate today with the premise that you have a good migration path to the future with both IP, HD, and thermal. Many instances require operating the camera just over a coax connection. They do want the digital Ethernet side, but all they have is the very old legacy analog camera cable plant, which supports a coax cable, and we can, with a special ER option, add an IP over coax component that allows you to use an existing analog coax cable to transport the Ethernet information over the coax down to your cabinet, where then you can connect it into your IP infrastructure from that point. So on the network video, again, I mentioned that we have a mix of both visible and standard def capability. You can configure up to at least 8 streams. So I could have 5 streams of visible, 3 streams of standard def. It's up to your imagination primarily. The command core video stream support is not hard fixed. It is dynamic, and it's up to the customer to determine how he wants to configure the streams. As well, we have very flexible streaming methods. There's widely adopted support of RTSP, RTP over UDP. Many players support that, very, very standardized. When you get into more difficult network topologies where there's firewalls and all kinds of security protections, HTTP tunneling, which sends everything pretty much over port 80, it basically allows you to stream through firewalls without much issue. And then in instances where you have remote cellular phone or transmitting equipment that does not have much buffering, where the video data sends just tremendous amounts of data very quickly, and sometimes that has a tendency to overload cellular modems that just don't have a large amount of buffering capability. So a constrained mode basically smooths out those very high spikes. So the way that you set up each of the streams has very good flexibility to match the network topology that your camera is connected to. So the motion control, the 4290 has 360-degree continuous pan. It's got 180-degree tilt movement. You can go straight up, straight down. If I mount the camera upside down, there's a mode button in the camera that just has it reconfigure itself. So the camera then, because it's got 360 degrees of total tilt movement, it knows to invert the video and then use the other 180-degree area of the tilt for being inverted. High accuracy presets. The traditional accuracy of positioners was about 1/4 of a degree. The RISE4290 is at 0.05 degrees. They're very important when you're using any kind of traffic analytics for pre-position accuracy. So at this point, you get much greater accuracy. The visible camera's got a faceplate heater that is designed to keep the outside faceplate of the glass above freezing down to -20 degrees Celsius, which is between the freezing down to -20 is the point where water has a more propensity to freeze. To get colder than that, generally it's going to be very difficult for it to start freezing. It's going to be so cold to begin with. But that faceplate heating system is a great mechanism to make sure you don't have ice buildup. And then in addition to that, the 4290 comes standard with the wiper system. In the 4260 it is an option, but in the 4290 it is standard. So you get it with the product when you order it. The ruggedization standard, the 4290 again is inheriting the ingress protection of the camera enclosures, the IP67 and IP68, where we purge and pressurize the visible camera. The thermal camera is IP67. The maintenance-free, basically, once it leaves the factory here, you will not need to do any further maintenance to those enclosures for the life of the camera. They are good for the life. There's no maintenance going back up and repressurizing necessary. Now, if in the event that somehow moisture did get into the camera head, then we have a lifetime warranty on any moisture ingress into the camera head enclosures. That is inherited as well from the RISE platform. We test all of our products to NEMA TS2 standards for temperature, humidity, and vibration, CE and FCC for emissions and electrostatic discharges, and then CISPR 24 for transients and surge protection. So the product has got all of the certifications that the RISE platform has, and in addition, the lifetime warranty on moisture ingress. Now, with all of that, the 4290 comes with a 3-year camera warranty on the camera system, as well as a lifetime, as I said, on the enclosure ingress. That's pretty much unheard of in the industry. So to wrap this up, we're just raising the bar on the performance of our products and achieving unbeatable pricing for the value. Our optics see better, longer range, at this point now no light. Interoperability, we designed the product to seamlessly integrate with third-party systems. And then the rugged design, we just make sure that it is the most reliable product designed to meet the most harshest installations. With that, the 4290 series delivery schedule at this point, we are accepting orders beginning October 1st of this year, just a few weeks away. And then delivery, and this is just the near-term delivery, but right now our fixed lens options, we see probably up to about 60 days for the lead time. The dual field of view up to about 90 days, and the 6X continuous zoom lens could be up to about 120 days, just to give you an idea of the availability. And that's the end of the webinar. Thank you for attending.